So the next thing we're going to look at is the 3D printing side of our little foam launcher project. There are a couple of different types of 3D printers out there. They range anywhere from a plastic filament taken up to the head, heated up to just below the melting temperature and extruded a layer at a time. That's called FDM, or fused deposition modeling. There's also a polyjet option, where after every pass it's going to spray out millions of droplets, and then a UV light is going to cure each different layer and build the part up a layer at a time that way. We've got 3D printers that can print in metal. We've also got 3D printers that will print circuit boards. So there's a wide variety of different 3D printers that are out there for getting our part done. Now, this part looks pretty good, but I've actually come in and I've got a little bit different version that we want to look at that's maybe a little more printer friendly. I've made a couple changes to the part. The first change I've done, I've actually come in and kind of capped off the end face here. I cut the cylinder back a little bit and put a little cap on there. The cylinder still kind of runs up in there, but it looks a little bit better when it prints. Another thing that I've done is come in and done some things to help out with support material. Now, we're not in zero gravity, we're not in space, so we're going to need some support material deposited to kind of take care of any overhangs or internal passages. So for this little hook here, it's going to need some support material underneath. But we don't want to have a big amount of trouble for cleanup. So I've actually gone in and done a few things differently here. On this hole and the other hole, I've actually come in and given it a little angled face to it. So if we come in and look at a section view, we can come in and see a little teardrop shape. You can actually come in and build this shape without any support material up inside that hole. So it's a self-supporting kind of arch there. So that's gonna save with cleanup and help with performance as well. Another thing I've done is I've come in and put a little cut on the little scoop here to allow the ball to come out of the holder a little bit better. Okay. So once we have this kind of done, most 3D printers that are out there are going to require some sort of STL file. So if we go to File, pull down, Save As, we can save out an STL file. Now before we hit OK, I want to take a look at some of the options here. The default angle tolerance here is usually 10 degrees. That's a little bit coarse for what we want to do, so I've bumped that number down to 1.5 degrees. If we say OK, we can hit save. I've already got this one saved out, so we can just overwrite that existing copy and go in and take a look at what we can do. I'm going to open up GrabCAD Print. GrabCAD Print can go in and open up the STL file. It can also open up step files, SAT files. It can even open up some of the native SOLIDWORKS files as well. But I went ahead and did the STL file for this one. For the Kids Camp launcher, we're going to come in and open up. There's the part file. There's the printable STL file. Now when we go to 3D print this, we need to look at orientation. The orientation is going to help us out with strength, aesthetics, support material removal, a couple different things with this part. So we're going to come in and orient this part. We can say auto orient face to plane. Maybe use that option. We can come in and choose this bottom face on our part. Say we're going to align that with the bottom and kind of go from there. When the STL file came in, it looks like it's got some errors. You've actually got options to come in and repair the model. So there may be a little triangle or something that was off on the STL file. So we can repair that real quick. Depending on how the STL file is exported, there may be an issue there. We've got this guy set up based off of a Fortis 400, 450, 370. There's a bunch of different types of 3D printers that we can choose here. We can come in and look at the material, the slice height, a couple different things there. We've also got the ability to come in and look at a slice preview. So this is going to go in and cut the part up in layers, figures out where it needs support material, and actually kind of build the directions for how to lay down each layer. And we can kind of look at that layer by layer and make sure everything's okay, and even animate some of the results there. So we can kind of drag the slider up and down and see what's going on. Right now it's showing us all layers. We can say maybe up to that layer. We can come in and kind of slice through here. Do we want to see where the support material is at? Do we want to show just that single layer? We can come into the top view and scroll down through there. We can see the layers building up a layer at a time. And the gold material is the support material. The green is the model material. So that looks pretty good. So once we're okay with this, we could come in and we can duplicate this part. Looks like we can fit about 30 in here on one tray at a time. And we can come in and look at an estimate for how much time it's going to take to print 30 of these guys. And so we've got 14 cubic inches of model material, 6 cubic inches of support material. It says it's going to take about a little over 17 hours. So printing these in groups like this can definitely help with the print time. We can come in and save this as a project so that we can just open up this with all 30 of them located together here and print it over and over again. Once we want to get these printed, we can just hit print, and it sends the files to the 3D printer, and then we have to go to the printer itself and hit the start button, and then we should be ready to go. So that's a little look at 3D printing with these parts using the GrabCAD software. So I hope that gives you an idea of what we can do with a 3D printer.